Okay, so the topic for today's presentation is called air masses, and I need you to write that across the top of your page before we get started. Your instructions for today, you can see them here. You're going to summarize the content of this lecture, and you should define all red bold-faced words, and you must copy and answer the check for understanding questions that you'll see after each section. If you don't copy the questions and then write the answers, you are not going to receive a done stamp for doing the assignment. First of all, just a revisit, talking about temperature. The factors that affect temperature. We know where you are in the planet, and that insolation, the spreading of sunlight, that greatly impacts how hot or cold you are. Your elevation, big difference. Are you close to the water, away from the water, and are you East Coast or West Coast? Severely impacts your temperatures. You got that little urban heat island effect, and finally, we know that temperatures change between the seasons. Okay, now think about Atlanta. Think about all these variables: the date of the season, where you're at on in terms of latitude, your elevation. All of these things affect the temperature of a location, like where we are here in Atlanta. That determines the temperatures for that spot. Well, let's consider this situation here. January 24th in 1943 at 7:30 a.m., the temperature in Spearfish, South Dakota was -4 degrees. Okay, we don't know much about Spearfish, South Dakota. You just got to trust that its combination of sunlight, latitude, proximity to water, what season it was, all of that led to a temperature of -4 degrees on that date. But 2 minutes later, the temperature was 45 degrees above zero. That's a 49-degree temperature change in 2 minutes. That is a world record still to this day. And by 9 a.m., the temperature had gone all the way up to 54 degrees. But then it tumbled back down to -4 after only 27 minutes. So the question is why? We understand all of these factors that affect temperature, but how are these things changing temperature so quickly? And we know that temperatures can change dramatically. If you think about this situation here, well, on Sunday, it was 90 degrees, and something happens the next day, it's much colder. And we see this in our forecast. Here we are, we're 70, we're 56, we're 45. Our high temperature has changed here by 25 degrees over the course of 3 days. So what causes that? Is it the fact that your elevation has dramatically gone down? No. Your latitude hasn't changed. You're not picking up being closer to or further away from water. You're not changing which coast you're on. And this isn't a situation where the presence of an urban heat island all of a sudden snuck up or disappeared and changed your temperature. All of these dramatic temperature changes are explained by what we call an air mass. First of all, I want you to consider that we have an area on the planet and it has air over it. And we know something about the temperatures of a place up here. It's pretty far north. There's a certain elevation, gets a certain amount of sunlight. So that means the air that is generally over that very similar area is going to have a certain characteristic, a certain temperature and or pressure to it. But think about the air that's over this position on the planet. Well, now it's a lot different. It's going to be a different chunk of air because it's a lot warmer. It's over water, so there's going to be a higher water content. It's getting more sunlight. So these air masses have very distinct characteristics based on where they're at, which their temperatures come from all of the previous things that we've talked about. So we get distinctly different chunks of air on the planet. And they are primarily categorized by two different characteristics. One, their temperature. Are they hot or are they cold? And how much water is in that air? Is it a chunk of wet air or is it dry air? This idea of an air mass is we have a chunk of air over a certain location that has a set temperature and or water content. That's what an air mass is. And when we talk about air mass, we're talking about big chunks of air. We're talking about the size of, you can see up here, a couple of states. That's the size of the chunk of air we're talking about. And because temperatures have regular patterns, we get some very distinct air masses that are kind of predictable based on what we know to be true about a certain area. For example, the chunk of air that's over Canada is generally cold because it's so far from the equator, and the chunk of air that's over the Gulf of Mexico is generally warm because it's a lot closer to the equator. But what about these two? Well, these two are both closer to the equator, and they are both going to be what we call warm areas, but they're different because of their different water content. One of them has a lot of water in it, and the other one doesn't. And we can actually see this in photographs. Here we've got two distinctly different chunks of air. We've got air over here that's got a lot of clouds. Well, clouds are made of water. So there's a chunk of air that has a lot of water. Well, the air right here is dry. You can see it because there's no clouds. Same concept here. These are two different chunks of air that we can't really tell much about the temperature, but we can certainly see the difference in the amount of water content between one set of air versus the other, and you can see it very dramatically. So how do we describe and identify these distinctly different air masses? Remember, it's temperature and water content. The first thing we want to say, is it a hot or is it a cold air mass? And there's some terms that we use to describe that. We use the word polar if it is a cold air mass or someplace or air that has come from someplace closer to the poles where we know it to be colder. And a tropical air mass is a chunk of air that comes from the south or someplace where it's warmer, where they're getting more sunlight. But then we also got to describe the water content. We use this word continental, continents, over the land. An air mass that is over the land is said to be continental, and it is considered to be a dry air mass because it's not over the water. On the other hand, a maritime air mass is one that comes over the water and is said to be wet because it's got a lot of water in the air from the water that it is over. So the final names for these air masses, we describe that air mass as being a continental polar. It's continental because it's over the land, and it's polar because it's from up north where it's cold. This would be described as a maritime tropical. It's over water, it's over that Gulf of Mexico, but it's tropical. It's down south. As opposed to these two, we still got the maritime tropical, but a continental tropical. So we need both of these terms to describe each air mass or to name each air mass. Now, we don't really want to write this out each time. This gets kind of lengthy and wordy, and if we're trying to put it on a map, well, then it's going to run all over the map. So we can abbreviate this. We can abbreviate with the letter C for continental and the letter P for polar. We're going to write something like this. That stands for a continental polar air mass. And we know that continental means it's over land or dry, and polar means that it's cold. A maritime tropical would be little m and big T. Maritime is over water, and T, it's tropical. So some rules here. We generally use a lowercase letter for the continental or the maritime. And then we use an uppercase letter for the tropical or polar, the temperature part. So once again, we're going to go little c, big P, little m, big T. And these aren't the only two examples, but this shows you how we're going to identify one chunk of air, one air mass from another. So your first check for understanding, here's what you should have gotten up to this point. What is an air mass? How big is it? Like, how did I describe the size of the air mass? What are the two characteristics that are important about these air masses? What do the words polar, tropical, maritime, continental mean? How are they named, and how do we abbreviate their names? This is the information you must have in your notes and in your brain for understanding. Now, in North America, there are actually 6 distinctively different chunks of air or air masses that determine our weather. And we're just going to look at North America. There's a lot more worldwide, but we're going to stick to North America. This is where we live. You're going to come see me now. I'm going to give you this map, and this is going to identify the different air masses by a number. And you're going to glue this at the top of your paper, and underneath it, you're going to have 1, 2, 3, 4, 5, 6. And you're going to write a summary of each air mass as I go through its description. And if I summarize the key information, we're going to name it. You're going to talk about how wet, how dry, how hot, how cold, what kind of weather impacts that air mass brings to an area, and what part of the country does it impact. So, first of all, what would we call air mass number one? Well, we're going to say, well, it's out here over the Pacific Ocean. So I'm going to say, okay, that's a maritime air mass, isn't it? But it's up north, so I'm going to call it a maritime polar. Well, the problem then becomes, well, what about number three? Well, it's over the Atlantic Ocean, so it's still a maritime, and it's still polar up north. Here we got a problem. We've got two maritime polar air masses, and this is true. We have two air masses that are over the water and that are up north. So we got to make some distinction between the two of them so we know which one we're talking about. We're going to name number one the maritime polar, and then you see in parentheses Pacific, the one that's over the Pacific Ocean. So my maritime polar Pacific. I want you to think about what you know about the Pacific Ocean. Pacific Ocean, big bucket of water. Temperatures don't change a whole lot. Pacific Ocean always stays relatively cool. There's going to be a fair amount of water in that air. Where does it impact? Well, this is the guy that comes ashore in the northwest United States. I'm going to reference some large cities that you might know, and they're in this area. Seattle, especially, Portland, Oregon, the Northern California coast. These are all areas that have their weather and climate directly driven by this air mass, because that is the air that is coming to them. Well, here's what Seattle typically looks like. This is what we associate with Seattle. Kind of cloudy, kind of rainy, kind of dreary, not particularly warm. And that makes sense because the air that is coming to them is on the cooler side because it's over the Pacific, which never gets really hot. And it's going to have a fair amount of water in it because it's air that's picking up water as it moves across the ocean. So kind of cool, rainy conditions is what we associate with Seattle. You can see this all around the Pacific Northwest, just moss and ferns, and everything looks kind of wet all the time because they are constantly getting this cool, wet air out of the out of the Pacific Ocean. There's kind of a joke in Seattle. Here's the seasons of Seattle, and you'll notice the continuity here is seems to always be raining. And that makes sense because the air mass that is constantly hitting them directly is always bringing moisture to them. Saw this in the airport in Seattle. It's kind of a fun joke. The Washington Rain Festival. You notice it starts January 1st and ends December 31st. Basically, they get rain year round because they're always getting that same air mass all the time. There was a graphic that I pulled off the Weather Channel a few years ago, 2019. They went 80 days straight without having a clear day because the air that comes to them is always that maritime polar air mass, got a lot of water in it, so it makes it very cloudy and rainy for long periods of time in Seattle. So kind of a quick summary here. It affects the northwestern United States, Seattle, Portland, Northern California. Their weather is directly driven by this air mass. It makes it cool, but they don't get really cold. Why not? Because the Pacific Ocean doesn't ever get super cold. So even though they stay on the cool side, they don't get very, very warm. They stay cool. They also always tend to have wet air. That part of the country never gets really hot because that air mass coming to them stays cool like the Pacific Ocean stays cool. And finally, it makes the Northwest famously rainy and dreary and cloudy. Now, we also want to note what impact does this air mass have on where we live here in Georgia? The answer is none. This air mass never comes to us, never causes us any change in our climate or weather. We're too far away from that part of the country. So let's go to the continental polar. Now, the continental polar, continental means that it's dry and polar means that it's cold. This is the guy that comes down from Canada. We famously refer to this guy as a Canadian air mass. We know Canada's way up north. It's fairly cold. They're not getting as much direct sunlight. It also tends to be drier air, which can change temperatures a lot more easily. So that means this air temperature can get pretty cold. This is an example of what a continental polar air mass would look like. It can be really cold, but you'll notice not many clouds in the sky because there's not a lot of water associated with a continental polar air mass. Here's a situation where we can tell it's cold, but look at the sky. There's no clouds up there. That's a cold, dry air mass, and that's what a continental polar air mass is. So this guy comes down from Canada, and where can he go? Well, this guy can end up coming a lot of different directions. Can this guy get to Georgia? The answer is yes. And when this guy comes to Georgia, we end up getting cold. These are both pictures from Georgia. The continental polar air mass came all the way to Georgia in the wintertime and brought us nice, cold air. Froze the fountain at this restaurant in Buckhead. This is the rock wall at Centennial where water coming out of the side of the rocks froze solid because it got so cold. But look at the sky. No clouds up there. When the continental polar air mass comes to town, it's dry air, and that's very typical for us. When we get cold, we're dry. It's one of the reasons why we don't get a lot of snow, even if it's cold enough for snow, because the cold air coming to us is dry air. Here you can see a situation where that continental polar air mass has come down from Canada, and he is coming south. That's how we get our cold air, is that continental polar air mass travels down through the middle of the country and eventually can get all the way here to Georgia. Now, where he doesn't usually get to is Florida. Usually that continental polar air mass can't push, it can't make it all the way from Canada all the way to Florida. It's one of the reasons why Florida, again, doesn't ever seem to get very cold. And they stay pretty much warm year round. A lot of jokes about that. The Florida winter outlook. You can see this 80% chance of morning sweaters. Too chilly for the beach. What's a fireplace? Land of permanent flip-flops. Because in order to get the cold air is not coming from Florida. It's coming from Canada. And it has a hard time getting that far south to make Florida cold. So in summary, that continental polar is cold and dry. It affects almost all of the United States east of the Rocky Mountains, except usually Florida. Does it matter to us? Yeah. This is why we get cold. In the wintertime, if we have a nice, really cold day, it's not Georgia air that's cold, it's this continental polar air mass. But it doesn't usually bring us snow. Now let's look at that maritime polar on the Atlantic side. It's maritime, so it's over water. It's going to be wet. It's going to be cold. Here we can get a sense of this. Here we go. We got a maritime polar air mass in Maine. It's foggy. We can see all the water up here in the sky. We can see all the snow that's down here, and we can tell that it's cold. But it's also wet. We've got cold, wet air. The northeastern United States can have very famously strong blizzards, and it's because of this air mass. This air mass is already bringing cold air, which we need for the snow, and it's bringing the water for the snow. So when that air mass comes to shore, it can very famously cause very large snow events in the northeast United States. But these two guys, they're both maritime and polar, but this guy here makes a lot more snow than the one over here. The question is, what's the difference? Well, it goes back to those ocean currents. This air mass over here is riding that Labrador current, which is a cold water current. The currents over here aren't nearly as cold because Alaska kind of blocks the coldest water from coming down. So this current over here is much warmer than the Labrador current. So the maritime polar Atlantic air mass gets colder, has more water in it, so it can therefore cause more snow and more precipitation. So, summary there, it's cold, wet air. It makes Boston, New York, anything in the Northeast have snow and blizzards. What difference does this guy make to Georgia? Absolutely nothing. Now, the maritime tropical Atlantic. This is the big player for us here in Georgia that we're going to talk about a lot. Okay, what do we know about this bucket of water down here? We know the Gulf of Mexico fairly shallow. It's nice and enclosed, gets a lot of direct sunlight. This is a big bucket of hot, steamy water. Well, this bucket of hot, steamy water can move like this. It can come out of the Gulf of Mexico and bring that hot, steamy water with it. That air mass is the reason why Florida is covered with water, why there's so much swamps and surface water, because that air mass that's parked over them is constantly dropping all of that water onto Florida. But it also keeps Florida from getting too hot. We know that the water in the air doesn't heat up very easily. So if Florida is covered by this maritime tropical air mass, it's full of water, so it's not going to get real hot. It's the reason why Tampa, Florida has only ever hit 100 degrees one time. Now, it's generally always warm, but it can't get super, super hot because the air is too wet. All around the Gulf Coast, Louisiana, southern Mississippi, famous for huge, huge swamps. And that's why they're so swampy, is because this air mass is constantly bringing water out of the Gulf of Mexico. Think about a swamp. It's wet and it's hot. The reason why we have these swamps there is because of that air mass. Now, this air mass makes a big difference for us. We have lots of rain here. This gives us lots of plants and trees, and that's because that air mass coming out of the Gulf of Mexico brings us nice, warm, moist air that gives us the precipitation for all of these plants to grow. So I'm going to change the wording here because I want to emphasize that air mass is not just hot and wet. I'm going to say it's dripping wet because it literally is. It is so full of water that it drives a lot of the precipitation that we get in the South. And it's the reason why we have those hot, humid, sticky, uncomfortable summer days. This air mass is the reason why most places in the eastern part of the United States get rain. This is the rain driver for the eastern half of our country. Now, for us here in Georgia specifically, it gives us our humid air, it gives us the huge amounts of rain that we get, and it keeps us from ever really getting too hot or too cold because remember, this is wet air that won't change temperatures as dramatically. Now, the continental tropical, this is coming out over this area. Northern Mexico, central Mexico, southern Texas, where it's over land, but it's also dry. Well, remember that dry things heat up easily. So this air mass sitting underneath that more concentrated sunlight gets pretty hot pretty fast because it doesn't have any water in it because it's coming over land. So this is what that continental tropical air mass does to this part of the country. Almost anywhere in this central part of the country can be impacted by this continental tropical air coming this way, which means basically that it's hot and it's dry. And you can see that in all of the pictures shown to you here. It's the reason why a place like Las Vegas can get these kind of temperatures. If it were hot, wet air, it'd be very difficult for those temperatures to get that high. But if it's hot and dry, well, then the temperatures can get up exceptionally high. So in summary, it's hot and it's dry. Pretty much only the middle part of the United States and the Southwest. This is why we have deserts in that part of the country. Most of you know that we don't have deserts in the East. We can't. We get too much rain. The impacts to Georgia, none. This air mass never makes it to us here in Georgia. Now, the maritime tropical Pacific. This is the guy coming off the Pacific Ocean and hitting Southern California. So this water out here, it's not particularly hot, but it's also not particularly cool. Relative to this air mass, it's going to be a little bit warmer because it's further south, so the water there is a little bit warmer. This air mass isn't dripping with water, though. So when it comes to shore, it doesn't make a lot of clouds, doesn't make a lot of rain, and this is why sunny Southern California is famous for its climate, because it is sunny, very little rain. Now that we got these two maritime tropical, we got this one and we got this one, and they're very different. One holds a lot more water than the other. The question is why? Well, if we think about which water would evaporate more, certainly the hot water is going to evaporate more. You can see the steam coming off. Well, which bucket of water is hotter? It's going to be this one because the Gulf of Mexico is shallower. It's more contained by the land, so it heats up really easily, gets a lot of direct sunlight. The Pacific Ocean is too big. So even the Southern Pacific can't get hot enough to have a lot of evaporation. So that maritime tropical Pacific, it's warm, but it's not very wet. And this keeps the southwest USA, the Southern California, sunny and not too hot, for which they are famous for their climate. Impacts to Georgia? None. That air mass never gets to us and impacts our weather. But let's take a look at a state kind of in the middle and talk about how these air masses can make a really big difference with one versus the other. We're going to look at Texas, because Texas is kind of right in the bullseye. It's in the middle of all of these air masses. So here I am in eastern Texas, and you can tell by the view behind me. Look at all of those trees, and look how wet and swampy the ground is. This is a place that gets a lot of rainfall, and that's because here in East Texas, they are primarily influenced by the maritime tropical air mass coming out of the Gulf of Mexico, which that maritime tropical air mass has a lot of moisture in it and creates a lot of rain, a lot of precipitation, which means a lot of trees grow and there's a lot of water on the ground. So once again, East Texas, where all they get is the maritime tropical, that warm and wet air mass out of the Gulf of Mexico. So I don't know why it appears this is muted, but this is West Texas. And you notice it's a lot drier back there behind me because now we're under the influence of the continental tropical air mass, which is coming out of northern or central Mexico, which doesn't have any water in it. And you can see it's very, very dry because that's the primary air mass that impacts western Texas. So to look at Texas, East Texas pretty much gets this guy, a lot of rain. West Texas pretty much gets this guy, hot and dry. Well, what about Central Texas? Well, Central Texas gets a little bit of both. So you notice it's not quite as green as East Texas, but it's certainly not as dry as West Texas. So your next check for understanding here is just to make sure you have all the summary for all of these 6 air masses, describe if they're hot or cold, dry or wet. What difference does it make to what part of the country? And more specifically, we need to reference Georgia. And we need to be able to understand the answer to these questions. Why is it hot and humid here? Why do we ever get cold? And why don't we typically get snow even when it is cold? Now, how do these air masses move around? I get that there's a certain air mass in Canada that has a certain characteristic, but how does it manage to move to Georgia? Well, ties to our air pressure. Remember, the air pressure is the pushing from air molecules. Now we got different chunks of air and they're pushing on one another. So one of them can win the push and push to a new location. Something like this. We know the high and the low, if they get to pushing on each other, the high is going to push into the low. So high pressures tend to be from places that are cooler. And if we think about this guy gets cold, builds up a lot of pressure, he can push into a lot of different parts of the country. So it's that air pressure that allows an air mass to push itself to a certain location. Well, the pressures, remember, are caused by this global circulation of rising and sinking air. Our Hadley cell, here the air is hot and it rises, and then it has to move towards the poles, and then it gets cold and it sinks. So we tend to get high pressures here, and we tend to get low pressures here. But remember, the Earth doesn't stay oriented like this year round. In the summertime, our hemisphere is getting a lot more sunlight, so the air is rising a lot more, even up near the pole, because remember, they're getting some sunlight, sometimes 24 hours of sunlight. Even though it's weak, they're going to have a lot more low pressures being formed because the air's getting more sunlight. Well, where's the high pressure? Well, there isn't as much high pressure, because remember, for high pressure, we got to have the air sinking when it's colder. So 6 months later, I want you to think about this part of the Earth up here. We still get some fair amount of air rising here at the equator, and it travels this way, and up at the pole, it gets really cold because it's no sunlight time. So the air is getting really cold and it's really squeezing together and makes a lot higher pressure. So the ability for an air mass to push depends on its pressure, which is dependent on its temperature, which changes dramatically between the seasons. So we get something like this. My air mass up here, when it's wintertime and the air is getting really cold and really sinking, can build up a lot of pressure. And if it builds up enough pressure, it can push itself to Georgia and make it cold for us. Now, I want you to say, Joe, when does that happen? Does that guy come visit us this week? We don't get cold. We don't get that cold in October, do we? We don't get this guy coming into town until wintertime, because that's when it is cold enough up here for the pressure to be high enough for that guy to push all the way to Georgia. Now, on the other hand, in the summertime, wouldn't we just love it if this guy was able to push to us in the summertime and give us some nice cool air? He doesn't, though. We're all hot and humid in the summertime. We never get any cool air in the summertime, because in the summertime, you don't have the high pressure because the air isn't sinking, because it's getting enough sunlight to stay rising. So you don't have the strong high pressures that are able to push that colder, cooler air all the way to Georgia. Well, this also explains why does it not get cold in Florida. We have this high pressure up here, and in January he gets a really, really strong, really, really high pressure, and he can be bold, and he can have the force to push himself to Georgia. We might be below freezing, but that guy very rarely ever makes it to Florida because he runs out of an ability to push. The pressure starts to drop as that cold air mass comes south. It doesn't happen instantly. It takes a couple days. What do you think happens to this guy when he comes to Georgia and stays here for a couple days? Well, he's in Georgia sunlight. He's going to get warmer. He's going to heat up. Think about cold temperatures in the wintertime. Do we ever stay cold for 2 weeks in a row? The answer is no. Because even though this guy's gotten enough pressure to push to Georgia, once he's here, he's sitting outside in the Georgia sunlight and he warms up, and he's not so much cold air with high pressure anymore. He becomes just Georgia air. So what about Florida? Well, as it turns out, most of the time, that high pressure air, that continental polar air mass out of Canada, about the best it can do is usually push to right about there. Because by the time it gets to Florida, well, now it's going to mix with the really warmer air in Florida, and then it's not going to be cold air anymore. And this is one of the reasons why Florida doesn't tend to get very cold in the wintertime. Now, that being said, you can have kind of an extra strong high pressure. Every now and again, this guy gets big enough and strong enough, and he can push to Florida. And when it does, it's national news. That's when people in Florida have to wear jackets. They maybe get temperatures down to maybe freezing, and it's big time national news because this guy doesn't usually build up enough pressure to be able to push himself all the way to Florida. So your final check for understanding is, when is that continental polar air mass? When is it strongest? When is it weakest? Why does it never seem to get cold in Florida? And why can't we get cool air in Georgia in the summertime?